Hi, my name is Land Grant of Tech Empowerment. I'm here today to introduce a clip from a trade show that I attended yesterday, the 23rd of April, at the Jacob Javits. This was the 3D printing show, or better officially called Inside 3D Printing. It's a conference and an expo that was at the Javits. It was rather small by Javits standards, but it had 3,000 or 4,000 very interested people there. And I was able to catch both the conference parts of it, the exhibitions, and the interplay with attendees, which is always one of the best parts. What we're about to see is a display and demonstration at one of the exhibit booths that's of 3D Systems, perhaps the oldest player in the entire industry segment from South Carolina. They had quite a crew on the scene, and we're going to see them demonstrate one of their new products at the show itself. So here we go.
Again, this is part of reimagining the engineering desktop, because if you can create content in a couple of hours that would take an engineer 20 hours, 30 hours to do in CAD, it creates amazing efficiencies, and you can also go back over the decades and pull in content that was never in CAD. And that's really important, and that's the whole reverse engineering concept. So, I'm going to give it to you.
Alright, guys, I work for Rapidform, which is a 3D systems company. We're a reverse engineering and inspection software company that uses 3D scans for a number of different things. What I've got in my hand here is a Rapidform scanner. It's a 3D scanner. This is laser-based, and it's optically tracking these dots to position itself in space. So I don't have to leave this item perfectly static, and I don't really have to do too much just to capture 3D data. So what I'm doing right now is I'm just going to scan this into VX Elements, which is a little data acquisition software provided by Rapidform. You can kind of see that it's got a number of dots here and it's positioning itself, and as I move this over the part, I'm actually getting a 3D rendered image of this hubcap on my screen. And once I have this image, I can do a number of different things. So I'll get a little bit of a demo of just kind of some of this technology here, and then we'll move over to sort of where my expertise lies. So some of the reasons that you would be doing this, and kind of my favorite story that we've done in the past, is a story that we partnered up with Jay Leno in his Big Dog's garage. He bought an old car a few years ago, and he was doing a ground-up restoration of it. And unfortunately, there's a lot of parts for it that were beyond serviceable condition, and you just can't find those anymore. It's really difficult to find parts for a car that was made 70 years ago, and the factory doesn't exist anymore. So what he did is he brought us a old, busted-up thermostat housing that you couldn't find a perfect part for anymore that was manufactured. And he wanted to return everything to OEM quality. He didn't want to use aftermarket parts or anything like that. So he brought us this old thermostat housing. He had us 3D scan it, and then we were able to take that into our software and then create a CAD model off of it. What we did from there was we took it and rapid prototyped that in a 3D printer, just turned that CAD model into an STL and printed it just to make sure that, everything, all the assumptions that we made when we were reverse engineering that part were holding true, and it actually fit in the car. So instead of manufacturing a part with traditional methods that, takes a lot of time and a lot of money, we were able to just print one overnight in a 3D printer just to verify that it was going to work. Once we did that, we could kind of confirm that it was working correctly, and we machined it out of aluminum with traditional machining methods using a CAM program, and he got an OEM quality part for a car that hadn't been manufactured in about 70 years. So essentially you can kind of see what's going on here. I've got now a 3D rendered scan of my hubcap here, and if I wanted to do the backside I could, but I'm just going to assume that this is the gold scanners it was injection molded.
Latest release.
That's kind of nasty, so I'm just going to let it post-process. It should be able to clean up a little bit of that extra data that it took in, and it's going to give me a scan like this. Now you notice that that's not a perfect scan, so I'm going to have to do either a couple things to take that STL and jump directly into a rapid prototyping machine like a 3D printer, or if I want to do a parametric model, if I want to idealize it, make sure that each one of these ribs are perfectly identical. Let's say that this object that I had was maybe missing some data. Maybe it was missing one of these spokes, or maybe it had a dent in it or something like that. If I want to make a perfect model of it, what I'll do is I'll take this into XLR, which is my software, You can see that this is the scanner that I initially used to reverse engineer this. I'm missing a lot of the bolts here, I'm missing half of the spoke, but that's fine because I know that this spoke and this spoke are identical. So I'm going to use traditional CAD tools just like SolidWorks, just like Inventor, Pro E, that sort of thing. Very, very similar techniques to go ahead and RE this part. When I do that, I come out with a solid body. That solid body is generated from that scan. I'm using the scan to kind of dictate where these extrusions and revolves and everything are placed. So when I do sketches, I do a sketch-based thing. I can actually take cross sections of my scan, along certain axes, and then define my sketches out. During the entire process, I can use my accuracy analyzer to see how the body that I'm creating is conforming to the scan, the initial scan that I took. And I'm not going to be able to show that right now. Actually, if I deselect a few of these things, it'll let me do that. Yeah, it's going to take too long to kind of show that, but essentially now I have a perfect model of this part. So I can go ahead and turn that into a mesh so that something like a 3D printer will be able to read that. I've got...
This basically creates data that you can then feed in.
Basically, yeah, this is data that pretty much any solid modeling program can read. That's a CAD file, but I just did a full conversion to a mesh. So that's just one-to-one right there. And if I zoom in and hide my solid bodies here, you can see that that's actually a triangulated point cloud. And that's exportable as an STL. STLs are what you print. So if you wanted to make an exact replica of this, maybe you had 3 of them, and of course you couldn't find a Walmart nearby to create the 4th one or whatever. You could go ahead and just print yourself one, and it's the exact copy of the other 3 that you have. On this one in particular, not necessarily, because all I did was I modeled it in surfaces, and I assumed that it had a single thickness, that I just did an offset at that distance. And probably this isn't a 3D printed object. This is manufactured injection molding probably. So I assume that basically everything on this side is just repeated on this side at an offset distance. Then I can go back in and I can make modifications, just like if I were using a traditional CAD program, do these extrusions and make these myself. I was kind of lazy and I didn't bother doing that because it's a lot more fun to scan this side. But absolutely, you can scan both sides. Some of the mesh editing and cleanup and modification tools that we have in XLR, we're able to do alignments between multiple scans. If you've got an entire car and you have to continually move your computer or whatever, you don't have to scan it all at once. You can scan it.
I know what they are. We actually need to move on to the next booth, but they're going to be around until 4. So
absolutely, I'll be demoing this all day today. So stop by, and if you have any more detailed questions, come by and ask.